This lesson will cover factoring out perfect square trinomials. How do you know if it is a perfect square? The first and last term are perfect squares. Therefore, a squared, perfect square, and b squared is a perfect square. And this exists in both of the examples below. Additionally, the middle term must be twice the product of one of the factors from the first term and one of the factors from the third term. Below are two sample problems for factoring a perfect square. Notice that in both examples, the first term, second term, and third term all have positive values. In the first problem, the first thing we want to look at is the first term. The first term is x squared. So we want to look at what is the square root of x squared. And the square root of x squared is x. So that's what would go in the beginning of both of our parentheses. Next we want to look at our third term. What is the square root of 36? And the square root is 6. Because it's positive in the first, second, and third terms, we know that we can put a plus 6 in each of the parentheses. Our factoring is complete, but we always want to check our work. So following the FOIL method, we're going to distribute our factoring to verify that we have accurately factored. We look at first and multiply and get x squared. Outer, and we get 6x. Inner, we get another 6x. And last, we get 36. When we combine our like terms, we will end up with x squared plus 12x plus 36. So we've checked our work. Now let's look at our second problem. Again, our first term is x squared, so we immediately can place an x in each of the parentheses. But this time our third term is 81, so we want the square root of 81, which is 9. All three terms are positive, therefore we're going to have a positive 9 and a positive 9. Now we want to go back and we want to check our work following the FOIL method. First, x times x is x squared. Outer, x times 9 is 9x. Inner, x times 9 is 9x. And last, 9 times 9 is 81. When we combine like terms, we will end with x squared plus 18x plus 81, which matches our original problem, and therefore we have checked our work. Our next set of sample problems are still factoring of a perfect square, but in this case, our second term is a negative value. We do know that by multiplying two negatives, we will get a positive, which would help with our third term. And adding two negatives is going to remain negative. The first thing we're going to look at is our first term. X squared is our first term, therefore the first value in our parentheses is going to be x. When we look at our third term this time, we're seeing that we have 36 and our square root is 6. But we need to get a sum of negative 12. In order to do this, we would have to have a negative 6 plus a negative 6, and therefore negative 6 is going to go into each of our parentheses. Negative 6 times negative 6 still gives us that positive 36 that we need for the third term, but when we add the two, we will end up with our negative 12x. By checking our work, I'll show how this actually works out. So we're going to multiply the first values and we get x squared. We then multiply our outer values. Negative 6 times x gives us a negative 6x. Then our inner values, a negative 6 times x again gives us another negative 6x. And our last values, negative 6 times negative 6 gives us our positive 36. When we combine our like terms, we will see that our final answer is x squared minus 12x plus 36, which matches our original trinomial. Let's look at our second problem. Our second problem has x squared as the very first value, so therefore we can go ahead and enter x into each of our parentheses. We then look at the third term, and it's 81. The square root of 81 equals 9. But remember that this second term is a negative value, so the sum of the two has to be negative 18. So therefore, we're going to look at the fact that we need negative 9 times negative 9, which gives us our positive 81, but that negative 9 plus negative 9 will also give us our negative 18. Therefore, we're going to put a negative 9 in each of the parentheses. Now we're going to check our work. Looking at the first, we have x times x, x squared. Outer, x times negative 9 gives us negative 9x. Inner, negative 9 times x is another negative 9x. And negative 9 times negative 9, which is our last, gives us our positive 81. When we combine the like terms, we end up with x squared minus 18x plus 81, which matches our original expression trinomial. This brings us to our final 4 problems for this lesson. These are a little bit more complex because, as you notice, at your first term, it's not just x squared anymore, but we are looking at a value in front of there. There's a coefficient to our variable of x squared. Looking at our first problem, we're going to see that we have a 4 as a coefficient instead of just a 1. And because of that, we also want to look and see, is there a GCF, a greatest common factor? We have 4x squared, which we're going to go with the larger factors. So we've got 1 times 4 times x times x. In our second term, we have 16x. And we see this 4 up here, so we're going to go ahead and do the 4 times 4 times x. And that would give us 16x. Lastly, we look at the last one, which is 16, and that equals 4 times 4. So our greatest common factor, the only thing that's shared with all 3 terms, is the 4. So we're going to pull it out and put it in front of the parenthesis, but then when we fill in what's inside the parenthesis, we need to make sure that it would, through distribution, equal 4x squared plus 16x plus 16. Okay, as I said, we're going to put the 4 in front of the parenthesis. So 4 times x squared would give us our 4x. 4 times 4x gives us 16x. So we have the 4 on the outside of the parentheses, so all we have to do on the inside is put the 4x. And 4 times 4 is our 16. One of the 4's is on the outside of the parenthesis, the other 4 goes inside of the parenthesis. Inside the parenthesis is still a perfect square trinomial. So now we can factor out the perfect square, but this time there's no coefficient except for the 4 that's outside the parenthesis, and therefore it's already factored out. So we put the 4 on the outside of the parenthesis, we draw our 2 parentheses, we know that x squared is x times x. We also know that 2 times 2 is 4, and we have a positive second term, so therefore when we add 2 plus 2, we're going to get that positive 4x. In order to verify our answer, we would need to factor and then distribute the 4. So we're going to go ahead and check our work. So our first, x squared, our outer is 2x, our inner is 2x, and our last is plus 4. We want to make sure that we bring the 4 down from earlier. Nothing has happened to that at this point. I always recommend combining like terms first, but you don't have to. but I'm going to go ahead and combine those like terms. So we have 4 times x squared plus 4x plus 4. Now we're going to do our distribution. So I'm going to take 4 times x squared, and I'm going to get 4x squared. First term is checked off. Now I'm going to multiply the 4 times the 4x. I get 16x. Second term is checked off. I distribute the 4 to the left, which is 4. 4 times 4 is 16. And my third term is checked off. We have verified our factoring, so therefore, our final answer is 4, open parenthesis, x plus 2, close parenthesis, open parenthesis, x plus 2, close parenthesis. Another way that some students may write this is the 4, and then x plus 2 with an exponent of a 2. That would say that everything in that parenthesis has to happen twice, and therefore you would still end up getting the same answer in the end, because exponents must be done first, following order of operations. Okay, looking at the problem 2, we see that we have 9x squared as our first term. Factors of 9 are 1 times 9 and 3 times 3. Neither of those are going to go into 25 except for the 1, and therefore we're not going to factor a GCF at this point. Instead, we're just going to look at our perfect squares. The square root of 9x squared is 3x, so that's going to be placed into our parenthesis. Then the square root of 25 is 5 times 5, so the square root's 5. We notice that our values in our second term is positive, and therefore we're going to go ahead and keep everything positive. So we have plus 5, plus 5. Now, everything is factored as far as we know, but we do need to check our work and see if this all worked out for us. So we're going to multiply our first value term in each of our parentheses, and 3 times 3 is 9, and x times x is x squared. Then we go to our outer. 3x times 5, that's going to give us 15x. Now we're going to go to our inner, and 5 times 3x is also 15x. And then we look at our last, which is 5 times 5, and that's 25. When we combine our like terms, we will get that 30x that we need for that middle term. And we did get our first term and last term as well. Therefore, we have checked our work. Moving on to problem 3. We see that in our first term, we have 16x squared. So our coefficient is a 16. In our second term, we have a negative 32. So our sum is going to have to be a negative 32. And then in our third term, we have 16. And it's positive. So whatever we're multiplying, it's going to have to end up being positive, and a negative times a negative would do that for us. We also may notice that these do share a greatest common factor. So we're going to go ahead and look at what that greatest common factor might be. First, we know that x doesn't go across all three terms, so we're just going to look at the 16 and the 32. We know that 16 times 1 is 16, and so that's going to cover the greatest common factor for the first and third terms. We also can look at 32 and see, well, does 16 go into 32? And 16 times 2 gives us 32. So our GCF, or our greatest common factor, is going to be 16. So we're going to start with pulling that 16 out as our greatest common factor, and 16 times x squared is going to give us 16x squared. So the x squared goes on the inside. On our next term, we have negative 32, and we already saw that, well, negative 32x, sorry. We already saw that 16 times 2 would give us 32, and then times x would give us the 32x. We put our negative sign there because the positive 16 is on the outside of the parenthesis, and we just need the 2x to give us that 32x when we distribute 16 to negative 2x. And the third term is 16 times 1, so all we have to do is put a plus 1. Okay, we have a perfect square inside of the parentheses, so we want to factor that out. We leave the 16 alone, and then we draw our two parentheses. X squared, the perfect square right there. The square root of x squared is x, so that goes in each of the parentheses. Our third term is 1, and that is a perfect square because 1 times 1 is going to give us a positive 1. But remember, we need a negative number in that middle term, and the sum of our products must be that value. So a negative 1 plus a negative 1 would give us that negative 2x that we need. Now remember, we could simplify this a little bit more and write it as 16 times x minus 1 squared. That squares the parenthesis and still multiplies times 16. But I'm going to leave that off for right now so that I can do the FOIL method and then distribute 16 to everything just to check my work. So x times x is x squared. X times negative 1 is negative 1x. X times negative 1 is another negative 1x, and 1 times negative 1 is positive 1, sorry. We combine like terms and we get x squared. Whoops, I forgot to write down the 16. Don't forget to do that. If you don't bring down the 16, you might forget to distribute at the end. So going back to this, we have our x squared. We brought that 16 right down. And then we have negative 2x plus 1. Now if we distribute, 16 times x squared is going to give us our 16x squared. 16 times negative 2x gives us negative 32x, and 16 times 1 gives us positive 16. So we have checked our work. It is correct. And now I'm going to go ahead and write it as its simplest form. Now we'll begin the last problem. We have 4x squared minus 12x plus 9. Factors of 4 is 1 times 4, 2 times 2. When we look at the second term, we see a negative 12. And 2 goes into 12 and 4 goes into 12. But when we look at the third term, 9, 2 does not go into 9 and 4 does not go into 9. So therefore we do not share a greatest common factor among the three terms. So instead we're going to factor our perfect squares at this point. So the square root of 4x squared is 2x, and we're going to place that in each of the parentheses. Our third term, 9, the square root is 3. We need to remember that we have a negative value for our second term. So while we're putting the 3 here, we're going to want to put it as a negative 3 in each of them. Now when we look at the factoring, we can see that there's really no further that we could go. We can rewrite this as 2x minus 3 squared, and that would be simplest form. You really have the choice of writing it in either way. Let's go ahead and check our work. So our first, which would be 2x times 2x, is 4x squared. Our outer, 2x times negative 3, is negative 6x. Our inner, negative 3 times 2x, is negative 6x. And our last, negative 3 times negative 3, is a positive 9. When we combine our like terms, we're going to get the negative 12x that we want, and our first terms and third terms already match. Okay, so we've factored all of these trinomials. I want to go back and step back to problem 3, and this time I'm going to do it as perfect squares without the GCF. And this just shows you that it's another way you could still end up with the same answer. So first I'm going to erase all the work that we did first, and I'm going to look at what values we have in our first term and our third term. Okay, so looking at our very first term with 16x squared, we know that the square root of 16 is 4, and we know the square root of x squared is x. So 4x times 4x would give us our 16x squared. We then look at our third term, and 4 times 4 gives us 16. But we need a negative 32 for our middle term, so we're going to put subtraction signs inside each of the parentheses. Now when we see that, we may see our GCF at that point in time, and we notice that it's a 4. So we factor out the 4, and we get x minus 1 inside the parenthesis. We have to do that to the other parenthesis as well. So we have 4 times x minus 1. Now we might see that we should multiply the numeric values that are by themselves, and we would get 16 times x minus 1 and x minus 1. And we're back to our original 16 times x minus 1 squared answer that we proved through using the GCF initially. So even if you don't see the GCF right away, you can still end up with the correct factoring in the end. That completes this lesson, and I will be doing a lesson on perfect square differences, or the difference of a perfect square, I should say. So watch out for that video.